So hopefully you're here to learn about the fundamentals of the Lakehouse Architecture with Synapse. If you're not, you might be in the wrong room. Thank you so many people for coming along. That's pretty cool. First public talk in a long time, so thank you. I'm a cloud solution architect with Microsoft, work in Dublin. I don't know, these slides will be published, so you can follow me if you want, or you can not. It's up to you. So some of the things we're going to talk about today. What is Synapse Analytics and what are the parts? I'm not going to labor that point unnecessarily, but I just want to make sure we sort of level set with everybody. Second of all, what is the Lakehouse Architecture? Thirdly, where does Synapse Analytics fit with the Lakehouse Architecture? We hear about the Lakehouse Architecture, particularly with Databricks, but then how does that work with the Synapse ecosystem, and how does Synapse and Databricks work together? Finally, we're sort of going to talk about, when does the Lakehouse Architecture work, and maybe when does it not work, or when do you want to be careful about it? Finally, we're going to talk about tips and tricks and some conclusions. Hopefully, we get time to fit it all in. I'm going to mostly be focusing on the Lakehouse Architecture as an architecture design and the what of it. If you're particularly interested in the Synapse Lake database feature, which is in public preview, there's a wonderful session being run tomorrow at 12 by Erwin, who's up the back and can shout and make noise. So I'd encourage you to attend his session if you're really interested in that. So first quick poll, just so we kind of level set with everybody. Who's familiar with Synapse Analytics? People relatively familiar with it? Pretty good, yep. And I guess the second question is, who's using it? So it's one thing to be familiar with it, but are you actually using it? Fair bit. Cool, that's awesome. I think if you're not familiar with it, you're not using it, hopefully I'll cover what you need to know. So let's start with what is Synapse Analytics. If you've seen a Microsoft marketing slide, you've probably seen something that looks a lot like this. It's this unified experience, everything's there, it integrates with the Dataverse, it integrates with everything. And I mean, yes, that is the promise of Synapse, but I think everybody who's a technologist in the room would probably know that the reality doesn't always quite work that way. And so what I prefer to think about it as, in a very boring way, far less pretty slide, is it's a whole host of components. We've got a data lake service, so a data lake storage technology where we can store files, we can store objects from our data lake, we can apply permissions there, we can partition data there. We've got Synapse SQL Dedicated, the classic SQL Server, or SQL Server MPP engine that exists. We've got Synapse SQL Serverless, so a completely serverless technology that allows you, very similar to the demo Anna did, to just be able to query data from the data lake where you've got no internal tables. You've got nothing stored in like an MDF file type thing. You've also got Synapse Pipeline. So that's the technology that comes from Azure Data Factory, which allows you to orchestrate a whole host of technologies. And that might be some Microsoft technologies. That also might be orchestrating Azure Databricks. That also might be orchestrating or calling REST APIs, or those sorts of things. So you've got a very rich orchestration layer. Within that, you've also got Synapse data flows, or Azure Data Factory data flows. Very similar to Power BI data flows, except only in name. And that's a low-code, no-code way for you to develop ETL processes, similar to what you might have seen with other ETL tools or other ELT tools, to generate that in a GUI and then actually be executing Spark code. And it's a great tool for people who don't want to learn Spark, but they really want to leverage the power of Spark and the scalability of Spark. We've then also got Synapse Spark, so a true Spark environment where you can be writing Python, you can be writing Scala, you can be writing PySQL. You've got all of that capability. Synapse Link, which allows you to grab data at the moment from Cosmos DB and Dataverse, but you've also obviously seen today that that feature will be coming to Azure SQL, so your transactional data can come into your data lake. And finally, we've got Azure Data Explorer being integrated in that, which is much more for telemetry, real-time scenarios. I guess what I want to level set here is that there's a whole heap of different components. And when we say you can just use Synapse for that, which components are we actually talking about? And that's something that hopefully I can bring through this session, is you can actually see what's going to work and what maybe is not going to be so successful. So that is my intro to Synapse Analytics. I'm not going to, as I said, not going to labor that point. So then we get on to the second part of this conversation. So we've said, here's what Synapse is. we kind of then need to establish what is the lakehouse. So I always think a lakehouse is like, this lovely house on the water. That's what I always dreamed that it would be. The reality is it's not that. So let's have another quick poll. So who's familiar with the Lakehouse architecture? Pretty good familiarity, awesome. And then the second question is, who's leveraging the Lakehouse architecture? One or two hands, brilliant. So, and I think that's maybe one of the things that we often see is a lot of people familiar with this architecture, but when it comes to how do I actually get started and what does this mean for me, people aren't as familiar. So if we think about this, we've got a data lake, data stored in a hierarchical manner, massive object stores, we can apply permissions over the top of that. We have a lakehouse architecture that then takes those advantages from the data lake and adds in some of the advantages that we expect from a data warehouse. And so what we instead do is instead of having one layer that does both, so in a traditional data warehouse, you have a physical data warehouse as well as a logical data warehouse. We instead break those two components apart. So we actually have the files stored in a data lake. And then we've got a logical layer on top of that that gives us a lot of the advantages of a data warehouse. The advantages of that sort of architecture range from scalability, from simplicity, from being able to use different tools however you want, because you don't necessarily need compute attached to access your data. And we'll talk about that in a second. And then there's this idea of a Delta Lake. So is a Delta Lake a different concept? So a Delta Lake is just a data lake using the Delta format. And the Delta format is just an extension of the Parquet format with a transaction log effectively on top of that. And then finally, if you get into this space, you'll also learn about Databricks Delta, which is the combination of the format, which is Delta, with some of the proprietary features that Databricks can bring. And so there's a lot of confusion in this industry or in this area because of some of the ways these sorts of things. So what does the typical lakehouse look like, right? So in many ways, if you're a data warehouse developer, this will look relatively similar to what you're used to, right? You've got source systems on the far left. You're ingesting that data into a raw zone or a bronze zone. You will often be ingesting that data in some sort of format like Parquet, like JSON, like CSV. Some people always ask me, like, why would you bother with CSV or JSON for your raw zone? If you're taking data from a relational system, why wouldn't you just put it into Parquet or something directly? And if you've got a system that's quite unreliable on the source side, or you've got a team of DBAs who love making a ton of schema changes, sometimes it's really nice to have that format in a way that you can actually just start to do inferring schema over the top of that. So you can say, send this data to a Spark engine, and you tell me what the schema is, and then how am I actually going to conform those schemas to what I need in my second layer. And that's one of the reasons why customers often end up down that space rather than just going down the Parquet route. And then as we move to the silver layer and the gold layer, the cleansed, the curated, you can call it whatever you want. Personally, I'm not a fan of calling it bronze, silver, gold, but it's become an industry terminology. I just don't think it's very descriptive, is my personal bugbear. More and more what we're seeing customers use is Delta Lake and the Delta format across that. And that's because the Delta format allows you to much more easily be overwriting or making updates, upserts into a table, whereas the Parquet format, that is quite difficult and necessarily generally involves a complete rewrite of that entire table, or at least the partition of that table. And so we've got these different zones. You'd probably be, you might be using a staging zone or something in your data warehouse. You might be using something before you get to something that resembles facts and dimensions. Pardon me. And so those different zones are used for a couple of different reasons. So the first part of it is that silver zone is often great for your data science teams. A great way for them to get access to raw data that you've done a little bit of machination on top of. You've done some joins, you've made it a little bit simpler for them to work with, but it actually means that they're getting relatively raw data without having to do a ton of unnecessary joins across a ton of unnecessary joins. And then your gold layer might resemble something much more like a data warehouse, fact and dimensions, because that's often what your reporting tools are going to need. For some customers, that actually means they go to a 4-tier layer. It's up to you. I'd probably think 5 is too many. I probably think 2 is too few. 3 or 4, up to you. And it's up to you and when you're implementing this to figure out what your use cases are and how far down this path you necessarily want to go. One thing that I would really say is that a lot of customers get caught up in what should silver look like? Like, what should this layer actually look like? And what I would say is try and find things that are useful to you as a business, that matter, rather than trying to find something that is an architectural purity, but not very practical from an implementation point of view. In practice, what that means, I see a lot of customers do, cleaning up invalid records in the in the silver zone, and getting something away from sort of a quite, third normal form style design where you've got a little bit more joining, you've got, things getting a little bit closer to some sort of dimensional model, but you've still, you haven't gone that whole way to a dimensional model. What that line looks like is very different. So that's what the overall architecture kind of resembles. So then how do we marry these two together? Like, how do we bring these two objects, like what Synapse is and what the Lakehouse architecture is, together? So this diagram's got a lot going on, so I'm going to walk through this in a fair bit of detail. So what we see on the source side, right, is we've got source systems. So that might be SAP, that might be, whatever ERP system you've got a CRM, you've got a line of business application, you've got a payroll application, doesn't matter what it is. You're always going to have a whole host of source systems. Some of them are going to be fairly legacy. Some of them are going to be real pains to deal with. And that kind of is the way it is. You've also, though, got increasingly more of those sources being able to support Synapse Link. So if you're using Cosmos DB for part of this, you can actually just get that data where you don't have to be doing that extract and load into the bronze zone or the raw zone, right? We just take care of that as a company, like as part of the Synapse Link managed service. We just give you that data in a way that you can query without affecting your transactional system and without creating those sorts of problems. Dataverse is obviously supported there, so for customers using Dynamics 365 CRM and some of the other parts of Dynamics 365, that works quite well. And obviously Azure SQL will be part of that conversation. So that means that your requirements to develop like straight copy activities where you're, go to the source system, give me every record that's changed in the last day, bring that into the raw zone. Then I've got to manage whatever problems are happening on the source side. I've got a grumpy source DBA, production DBA saying that I'm causing unnecessary load or whatever the case might be. You kind of start to resolve some of those problems with Synapse Link. But at the moment, the scope of that Synapse Link is relatively limited. And you'd be doing that through Synapse pipelines. So you'd be orchestrating that process of copying data through Synapse pipelines. And one of the interesting parts of this is you can basically orchestrate this entire process through Synapse pipelines, as opposed to having to orchestrate that separately or manage any of this in a different way. So then we've got our data in our bronze layer, our raw layer. It's maybe in Parquet, maybe it's in JSON, maybe it's in CSV, maybe it's in whatever file format you want. How are we going to take that to the next layers? And that's where we've kind of got a couple of different tools available in the Synapse space. So the first one is Synapse Spark. Synapse Spark Notebooks. It's the Spark you know and hate. Maybe you love, but it's probably few people who would say that. And that gives you a full code-first environment where you can be using Scala, you can be using Python, you can be using Spark SQL. And note that's Spark SQL, not MS SQL or T-SQL, right? So it's important to understand that distinction. The second option you've got, and I've got 2 versions of that for some reason, is Synapse Data Flows. So Synapse Data Flows being able to move that data between different places. Synapse Data Flows is that GUI-first way of creating a transformation pipeline. So you might be doing joins, you might be replacing values, you might be whatever you're doing, but you're doing it in a GUI way, and then that is executing as Spark code. And the reason why I think it's important to understand that that is executing as Spark code is quite simple. How many people here have leveraged SSIS and tried to scale SSIS where you're not just using it as a fancy stored proc orchestrator? Many people? Yep. How did the scaling of SSIS go when you actually had stuff sitting in the data flow component? Yeah, that would be my sort of view. It's pretty problematic. Works on smaller scales, but as your data volumes start to grow. So knowing that your business users are developing in a GUI way, but that code is actually Spark code, like being executed as Spark code, gives you a lot more confidence that actually you can scale and you don't have to suddenly pull apart these horrible processes that maybe some business users have designed, or where the documentation wasn't very clear. Finally, we've also got Azure Databricks, right? So Azure Databricks is separate to Synapse, but it works really well in the Synapse space. So you can, with Synapse pipelines, call a Databricks job. You can call a Databricks notebook. Very easy to leverage the power of Databricks if you're already leveraging Databricks to do your data transformations through these stages. And it's not an all or nothing, so you can start to combine different parts of this. There are obviously complexities when you're combining different technologies, but on the whole, what I see in particular is a lot of scenarios you've got Spark, like code first, Spark environment, so Synapse Spark notebooks, or Databricks sitting between bronze and silver, and then from the silver to the gold, you know, you've got a bit of a mixture. You've got some business users who are pretty cluey. They don't want to use a code-first environment, but they're happy to use Synapse data flows to be able to orchestrate, to be able to transform that data from what it currently exists in the silver layer to what they want in the gold layer. And that's a really powerful way to be bringing business users into the data warehouse environment, the Lakehouse environment, to actually be able to deliver value in a way that they understand the data. They understand the data, so they're going to be able to deliver that value often a lot faster than anybody else will be able to. So we've got, we end up with our data in our gold layer. Happy days. How do we get it out? So you can just access these files from at a storage level. So if you're storing it in Parquet, for example, you could just leverage, for example, Power BI's capability to hit against Parquet files sitting in a data lake through Power BI data flows. You could do that. What most of the time I see is that technologies like Synapse SQL Serverless are being leveraged to enable business users or enable BI tools to be able to access that technology just through a straight T-SQL connection. So you can create those views for users where they're actually querying Delta tables. They can write normal queries, and they can then just kind of go from there. And it creates a familiarity. So you can use Power BI's SQL connection. You can also use Power BI's Synapse Workspace connector, which is in beta. You can leverage Excel really easily. You can leverage SQL Server Management Studio. You can leverage Azure Data Studio. You've got all of those tools that just natively work with the SQL Server protocol. And so Synapse SQL Serverless gives you that capability. But there's a bit of a problem with this architecture, right? If you've got data stored in a data lake, you've got an object store, basically, and then you've got a serverless query engine, what does the performance look like? Like that's inevitably the problem that people run up against. Because you've got compute that is being created on command, like you hit F5 on your SQL query, that we take that query, we figure out what we've got to do, we've got a whole host of things to do, then we go and get those files, and then we return it. And we don't have the advantage of secondary indexes. So all of those nice things that you've got with SQL Server to make those queries run really fast don't really apply in this world. And so that mostly means that customers have to be doing some sort of in-memory analysis technology. The reality is that, yes, you can direct query against Synapse SQL Serverless, and I would implore you not to. The performance is just trash. And I don't mean, that sounds like a very absolute statement, but Power BI and these in-memory technologies have made users expect a very quick response. They want, I even think 6 seconds is ridiculous. 2 seconds, I would personally have users who complain about a report taking more than 2 seconds to load when they start to filter something. And so because of that, what you generally have to be leveraging is some sort of in-memory analysis technology that you can do a incremental import into and then go from there. And that might be Power BI datasets are the classic one. So you can connect to Power BI dataset, leveraging Synapse SQL Serverless, turn on incremental refresh because it's ultimately a SQL Server-like connection, so it has all of those sorts of query folding capabilities that potentially some of the other technologies don't have, and you can get that sort of performance there. You can do the same things with Tableau because it's leveraging the SQL Server protocol. You get all of that sort of advantages. But if you've got users who want really fast reports, which most users, in my view, are pretty impatient, then you have to be going down that space. Now, sometimes that means you might be looking at Azure analysis services. You might be looking at Power BI Premium. Keep in mind, Premium per user exists. Premium per user is pretty cost effective, so you're not just talking about premium per capacity for smaller organizations. So hopefully that so far makes sense. So what components did we use, right? So I talked about the components of Azure Synapse at the start towards the start of this presentation. So what are the components we're actually using? So we're using the Data Lake service, Data Lake Service Gen 2, Data Lake Storage Gen 2, sorry. We're not using Synapse SQL Dedicated. Synapse SQL Dedicated at the moment cannot read Delta file format. So it can't read it without using some sort of staging technology like data flows, at which point what you're doing is you're spinning up a query engine to understand Delta to then insert it into an MPP technology. Not really the greatest use of time or resources. So that sort of capability does not exist at the moment. I want to be clear, that's at the moment. Things should change, but that is the way it is. We are leveraging Synapse SQL Serverless because Delta is completely supported in that format. And yes, we're taking a performance penalty on that space, right? The serverless engine is not going to perform as well as the dedicated engine because you don't have the data just sitting potentially in a cache or potentially directly attached to or relatively attached to a virtual machine. You also don't have the advantage of secondary indexes or result set caching, which the dedicated level has. But we're kind of augmenting and solving that problem by looking at in-memory analysis technology. We're leveraging the pipelines to orchestrate this process, to orchestrate the copy from the source to the raw, then through those different stages, and calling the different services that you might need along that path. We're leveraging Synapse data flows, potentially. We're leveraging Synapse Spark, potentially. You know, this is where you actually get some decisions about what technologies you're going to be leveraging. Potentially, we're leveraging Synapse Link as well. Just noting, Synapse Link has 2 sources that are currently supported properly, so if you need those sources, it works well. If you've got other sources, it doesn't work so well. And we're not really leveraging Data Explorer for the Lakehouse architecture as a general rule. Data Explorer works really well for IoT scenarios and real-time telemetry scenarios, but doesn't sort of go there. And what we therefore end up with is a bit of a view of where are we using what. And so this is probably one of the biggest things that I find I end up talking to customers about. Because they're like, Synapse SQL Serverless. We can write data out. We can do create external table as select, blah, 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 write a table out. And so then they're using Synapse SQL Serverless for transformation. The problem with that is that there's a lot of limitations there. Namely, that you can't manage the partitions appropriately at a data lake point of view without doing some fairly fancy SQL that somebody like Andy out the back can probably tell you all about. But also, you don't have the ability to sort of clear files natively within the SQL environment. So my personal view is using it for transformation it's nifty because you can use T-SQL, but it creates a whole host of other problems, so I would never consider it a transformation engine at the moment. On the other hand, great as a query engine, great to make data available. And by the way, when I say query here, I'm meaning like a user or a BI tool querying against it. I'm not talking about querying that data to then transform it. What about on the Synapse Spark side? So if you're familiar with Databricks, you'd be familiar with the idea that you can actually query a table through Databricks. And that's not really capability that's provided under Synapse Spark. So we see Synapse Spark as much more of a transformation engine to undertake data transformation to then persist it in the data lake that is then read out through things like Synapse SQL Serverless, as opposed to just being a transformation, as opposed to being a query engine. And that's a real difference that exists between Synapse Spark and Azure Databricks. We've then got data flows. Similarly, data flows are a transformation engine. You can use them to write out to different locations, but you can't use it to query that data appropriately. And then we end up with Azure Databricks. Because in Azure Databricks, we can query data. We can persist data in a way that actually has caching with it, with Databricks Delta. We can also, I need to fix my slide there. We can also use it for transformation. My apologies. So we get the advantage of both. One of the questions, though, that I have when people are using Azure Databricks for querying is how are you doing that querying and what does that querying look like? And what are the user expectations? So Databricks have a whole heap of enhancements related to caching that they can do on a query side that make it better. They don't solve it. And they don't solve it as well as something like Azure SQL solves it. So if you're wanting that really quick, single record lookup, you're wanting the ability to put a non-clustered index over the top of a query just to over the top of a table to make that query a whole heap faster, then Databricks you can push a little bit, but you can't push it to be a complete replacement for something like SQL. And that's just comes down to some of the fundamental different ways that these technologies are designed. So be careful about trying to over-optimize for a situation where actually your users do need direct query, they do need that data very quickly, then you often end up much more in the relational databases. And Azure Data Lake Storage really doesn't provide you with a level of querying or a level of transformation. So it is a data store at the end of the day. You can query that, you can grab the files there. So if you're, for example, using Azure Machine Learning, you could connect to that data lake to connect to those files. But you're not really using Azure Data Lake Storage as a query engine. You're just using it as a file, like a blob storage technology that you're grabbing those files from. So it's just important to do that. I will update this slide also before I publish it, in case anybody's wondering. So how and when does the Lakehouse make sense? Batch data or non-real-time reporting. So you might have parts of this that are real-time for other purposes, right? You're ingesting in a real-time scenario, that makes sense. But for real-time reporting scenarios, I think what you would find is that the Lakehouse with the Lakehouse architecture with Synapse, it's going to be a tough ask. And if you think that that's where you need to go, then you probably need to be reconsidering how you're doing that and what that real-time reporting scenario is. Because when I'm talking real-time, I'm sort of talking less than 5 minutes into a, from source into a Power BI report. What about scale? So I see this architecture scaling anywhere from about 10 gigs up. That's pretty impressive in that I see 30 gig warehouses, fairly small scenarios, very much once a day scenarios, all the way through to, sort of terabyte scenarios with the Lakehouse architecture. So it does scale across that. The one thing I would say is if you're really at the, the 10 gig, 30 gig, 40 gig limit, I mean, there's a whole host of considerations why Azure SQL is just not a hell of a lot cheaper and easier for you to manage. But if you think you're going to grow very rapidly, then those costs scale very linearly. And that's partly because the way the architecture is designed is very much using serverless compute on demand, so you're not constantly paying a certain amount of money for a certain level of compute, whether you're using it or not. And you have to accept some of the disadvantages there, but you get a whole host of cost advantages and a whole host of just being able to process a lot of data very quickly and then going down to very low cost scenarios. And then the final part is you've got to be prepared to accept a lot of modernization and rework. If you've got an existing SQL Server data warehouse that you're running on premises, and you just want to lift and shift that, you want to, maybe you want to do a little bit of modernization. You're going to move to a platform as a service offering within Azure. The Lakehouse architecture is not that. that is not the droids you are looking for. That is very much a scenario where you're going to have to do a fair bit of rework. You're going to have to do a fair bit of modernization. Now, I would probably argue for a lot of legacy data warehouses, you've got to deal with that technical debt at some time, right? If you're not paying down that technical debt, you will eventually get to the scenario where you're only paying interest on your technical debt. Your team is killed by the interest payments as opposed to ever paying down the principal of technical debt. I apparently think about technical debt in the same way I think about my credit card. So at some point, you're probably going to have to bite that bullet, but maybe you don't want to bite that bullet today, or maybe you want to do something more gradual. And if you're not prepared to accept that, then just be forewarned that shouldn't happen. So I think we've actually covered most of what I wanted to cover in this slide, which is just about, what does the flow of data look like? How does that actually work? What does that end up meaning? But I think we've covered that so far. So first tip, use the right tool for the job. If I go back to this slide here, once I update it, with Databricks being a tick for transformation. Make sure you're using the right tool for the job and don't try and beat a tool into submission. You will generally end up in a situation where things become quite difficult for you, or alternatively where things cost a lot of money. Inevitably in the cloud, there is this trade-off between performance, convenience, and cost. You can make some things perform exceptionally well, but you're going to pay a lot of money. And if you're not prepared to do that optimization, then sometimes you're just going to end up solving the problem by paying more money. You've got that trade-off. You have that trade-off on premises. It's just that the cloud makes it a lot more visible to you. So I don't necessarily think it's different. So make sure you're using the right tool for the job. And part of that comes down to, run POCs with different tools. If you're looking at the Lakehouse architecture and you're like, oh, do we go down Databricks for our transformation, or do we look much more in the Synapse and Spark environment? Run a POC. Some of the common considerations that I find customers considering between those two options, Databricks has a lot of additional capability there, has that query capability, has an ability to do a lot more real-time capability, and it's a much more mature product. And maturity in this case means that if you want to query, if you get an error in Databricks, you go on Stack Overflow, or you go onto Google, or yeah, let's be honest, no one's using Bing. You go onto Google, you type it in, and you go Azure Databricks. And the great part of some mature products is, you get an answer. You get the top answer on Stack Overflow exists, and you can see that. You can actually start to understand that. And maturity of products brings that level of community support. It also means that there are just more people who know about the technology. So if you're starting off in this space, then maybe that might work really well. On the flip side, Synapse Spark provides you with a lot better integration across the Synapse ecosystem. So if you want to really heavily leverage data flows, the capabilities between data flows and Synapse Spark are pretty great. The capabilities with with the Synapse Link capabilities for either Cosmos DB or Dataverse are also really great. So you've got that capability to be quite well integrated into that environment. And there's some of the trade-offs that you're going to end up running down. So use the right tool for the job. Make sure you POC it, and make sure it's not a POC that slips into production. 1 week, 2 week POC, and then kill it. Second thing, deliver horizontal use cases. So one of the big problems that I often see with customers implementing the Lakehouse architecture. So they're like, right, we've got this legacy SQL environment. We're going to go down the Lakehouse architecture. It's going to solve all of our problems. And they look at it from a vertical scenario. So they go, let's deliver the raw zone from all of our source systems, 3 months later, they've got a raw zone. They're like, all right, it's time to move on to our silver zone. Maybe that takes a couple of months across all of their different source systems. And there's always complexity. There's always changes that happen in most businesses. And so the problem is they're 6 months in. They're whatever cost in terms of the labor costs or consultants or partners that you've brought in, and they've delivered nothing to the business. The unfortunate reality for every data engineer in the world is business decisions are made at this level. People want to see a pretty Power BI report. And sometimes that breaks my heart when I've written stuff in the past about slowly changing dimensions, or we've had to handle something quite difficult, and you're like, oh, this is an amazing technical solution. But then it all comes down to the Power BI report, and you're like, all right, well, and I'm not good at Power BI. I'm not good at visual design. So instead of focusing on that, focus on how can you deliver a horizontal use case. That might be a marketing report. So you limit the number of source systems and you take that data right the way through. And I think this is probably a good lesson for all business intelligence, data engineering processes. But it's amazing how often the Lakehouse architecture or implementing a data lake starts off at, yeah, we're just going to get it to silver and then we'll figure out what we do with the data, because that doesn't matter. And we're going okay for time. Awesome. And then the final part is partitioning matters a bit. So one of the reasons that we have those different zones, right, is that the data is getting enriched through those zones. But also we're often changing the partitioning strategy of different tables within those different zones. So a raw zone typically looks like something like this. System, I don't know, CRM, table name, customers, year, 2022, blah, 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 blah. And it goes on. And it's usually decided on a last modified date. And that's because that's really easy to write into. It's very easy for me to just figure out what files I need, chuck them into the partition, and then be able to pick them up from that partition. By the way, when I'm talking about partitions in this particular context, basically they expose themselves as folders. You can think about that. So that makes sense at a raw zone. But obviously that doesn't make sense as you go through. And that's because the nature of the workload changes. At the bronze zone, I often want to be able to easily write that data in quite simply. But then as I move further along, I get into much more read optimized. So that might be if I've got a logical layer or a platinum layer. I don't know if people have a 5 thing architecture, what they call the one after platinum, but I'll be interested to find out if anybody's got a good idea on that one. They'll often be partitioning by very different things. So they might be partitioning their fact sales by sale date, or they might be partitioning their dim customer table by a certain characteristic about their customer. State is the common US one, but I guess country is a probably better one for a European context. So you get different partitioning across those different components. So it matters a bit, and you want to probably think about, particularly at the raw zone, what makes sense. Often going to be last modified. And then you sort of figure out what that looks like through to your end zone. So matters a bit, different zones are going to have it. Think about it more so from your raw zone, but then you'll probably get it wrong. And be okay with that. Be okay with the idea that 6 months in, 3 months in, some amount of time in, you're going to be like, all right, we've got to repartition this thing. And it's a big, expensive operation. It's actually going to be something where you rewrite out a ton of files. And you're just going to have to accept that. And be okay with not being able to architect everything perfectly from the get-go. So that's hopefully made a lot of sense. So the conclusions, really, other than, I guess, everything else I've said, is hopefully you know now how to turn this into something approaching this. And you actually understand maybe how the marketing starts to relate to the architecture. So we've got 9 minutes, 8 minutes or so left. So I'm going to take some questions and answers. So hopefully we'll see. Do we have any virtual questions and answers? Nothing. Yes, up the back.
So you talked about serverless.
Yep.
Don't recommend to use direct query to use serverless. I totally agree with that. But now we have hybrid tables, and on a partition level, we can get direct query data from servers. What is your standpoint on that? If that is just limited data, it's okay-ish, or still, you don't?
Yeah. I mean, it's better. It's still kind of bad. I guess what I see is a lot of customers say, I need that report to be quite snappy. And a lot of the stuff from a serverless point of view, you're talking about 10 to 15 seconds, probably for the query to the engine to respond. Maybe you can try and get that close to 5 seconds. You're never going to get it below 5 seconds generally, right? And even 5 seconds is a good time. and the serverless performance can sometimes be inconsistent. So hybrid tables can solve it if you absolutely need to, but even within a hybrid table, at least the last time I played with it, which was a while ago, so this might have changed given the feature is in preview. The results don't return until the hybrid table gets a response, and it's always going to issue a query to the hybrid table. So it's not even as if you filter to a certain time frame, it didn't seem to always necessarily be eliminating that direct query partition, at least when I played with it. So I think there's also a concern if you're trying to get that data recently, then how does that work? And maybe that's a case where you start to look at things like streaming data flows, or you look at the other sort of streaming data sets. I just think it's making a bad situation worse, but it's not making it a good situation, would be my sort of view at the moment. That might change. Hopefully that changes. Sorry, yes?
Virtual coming in, virtual question coming now. Is the main reason to use a lakehouse that it is cheaper than an RDBMS based equivalent at a given scale? And if so, how does Azure SQL serverless alter that assumption?
Azure SQL serverless or Synapse SQL serverless?
It says Azure SQL serverless. I think the question's mainly about cost comparison.
Yeah. I don't think cost is the main reason to make an architecture, like to make the Lakehouse decision. Because I think, yes, you can probably achieve lower running costs, but you're often trading off different costs. So for example, your Power BI costs might go up because suddenly you need an in-memory technology. Or alternatively, you end up changing maybe some of the way you work. The other part of it, I would say, is for most customers, there is going to be a higher implementation cost. So the idea that I've got a SQL server on-prem, I can just move parts of that into Azure, into Azure SQL, and even potentially into the Azure SQL serverless, which is different to the Synapse SQL serverless capability, might make sense. So I don't think cost should be the overriding view. I think the idea that you can get a little bit away from always having to have a query engine for your data to be being moved around, that you can be doing things much more on an event basis and much more on you can start to use some of the power of Spark to create data expectations. How many people have had an SSIS pipeline that falls over all the time because like the source system changes? Doing some of that like just neat schema inferring capability is a really good way to give you reliable data engineering pipelines. And that's a different way of thinking. Sorry.
And one more. Is there a place for Azure HD Insight in this architecture?
It's being recorded, isn't it? If you have an on-premises Hadoop environment, sorry? Oh, sorry. So the question is, does Azure HD Insight fit into this architecture? If you have an on-premises Hadoop environment, or you have a large Hadoop dependency that you want to be able to bring that code over, HD Insight makes sense. As a general rule, I would say if you're building this in a greenfield way, I would not be leveraging HD Insight. I think HD Insight is a great way for customers to migrate Hadoop environments into, certain Hadoop environments into the cloud, but it's not something I'd be building from fresh right now, is my sort of personal opinion. I'm not the biggest fan of I just think it's quite a complex service that customers need to be aware of. Customers who have managed an on-prem Hadoop environment are used to that complexity. Cool. Any other questions? Oh, sorry, yes.
In the latest slide, you talked about the house bit being logical.
Yep.
Dependencies and serverless. I'm guessing there are, at some point you might reach the stage where you've got to, maybe in addition, make the house physical. And if so, would you use the MPPs on Synapse?
Yes, you certainly can, if you've got the data volumes to justify it.
Broadly speaking, what does volume be?
So if you've got less than 60 million rows in your fact table, Synapse SQL Dedicated doesn't make a lot of sense. And if you're not prepared to run at a 1500 DWU, maybe a 1000 DWU or a 1500 DWU, and you kind of look up the price of that and get an idea of what that means, I would probably be saying I'm not totally sure that Synapse SQL Dedicated is where you want to be. Now, some customers who need that direct query capability for one reason or another actually might then make the Platinum layer basically a Azure SQL instance or an Azure SQL hyperscale instance, or yes, it might end up being a Synapse SQL Dedicated environment. Sorry? Oh, sorry. The question that was asked is, for this architecture where you've got large data volumes and Synapse SQL Serverless is exposing the logical data warehouse, when might you start to look at some of the other technologies like Synapse SQL Dedicated? I think that's a rehash of the question that's fair. Yep, cool. Another question at the back.
You mentioned data lakehouse is not very fit for real-time data strategy.
Yep.
When you go back to the slide and the topic, and if you would use Synapse Link and structured streaming and then serverless on top, why don't you advise that? You can easily get sub 5 minutes data pipelines with that.
Yeah, so I think it's important to note when I'm talking about non-real-time reporting. So I'm not necessarily talking about real-time data ingestion, I'm talking about real-time reporting, because where is that data then ending up? If you need a Power BI report that is updating in, like basically Patrick's demo earlier before, then that's quite hard to achieve because you have to basically end up in a direct query scenario, or you end up in a scenario where you're using streaming data flows, streaming data sets or something to augment that capability. It's not that the streaming part is the problem, it's the reporting part. The funny part of that is I don't so often actually see streaming like real-time reporting being that important, because often that's coming from the source system. Like that is the point of ODS reporting as opposed to data warehouse reporting. Certainly if you are in the real-time scenario, Databricks is a little bit neater to deal with from a Spark point of view than some of the other technologies. Yes, up the back. I've got 1 minute to answer this question. You can't basically do referential integrity, but the question I always have back to customers, and you can't do it in Synapse SQL Dedicated either. The question that I often have to customers is, why do they want referential integrity? Because referential integrity should be managed by your transactional system, or alternatively, it is a data expectation, right? So if I've got this many records in my sales line table, right, I should have those same IDs in my sales table. That's actually not a referential integrity issue when it comes to data engineering questions. I think it's actually a data expectation and a data testing issue. But I understand that that's a different way of doing, like a different way of addressing that, and then you'd be using things like Synapse Spark to be doing that data expectation testing. That's a very quick answer to what is a complex issue that I have some less polite feelings on. Or sorry, not less polite, like less, yeah, just a lot of feelings about over time. So, I know I'm out of time, but very finally, there is feedback. Please give the feedback. It matters to us as speakers. It matters to the SQL Bits administrators. It also means that for every 10 feedback forms that are submitted, they're going to plant a tree somewhere, I don't know where. So A, you're helping to save the environment, but you're also helping the conference organizers and us as speakers. And thank you so much to everybody for coming. Stay safe.